In today's class, we want to talk about the calculations under pH. Now the first one is calculating pH and pOH when concentration of H plus and that of OH minus are given. The next one is calculation of pH of an acid or that of a base. Now an acid can either be a strong acid or a strong base. We can also have a weak acid and a weak base. Welcome to Delzy's online school. Please, if you're new to this channel, please kindly hit the subscribe button, like our videos and share. This is where we actually give you guys the very best. Thank you. So first, let's look at pH and pOH expression. Now pH can be expressed as negative log of H plus or negative log. Now these are the two expressions for pH. They are mathematical expression, whereas pOH is negative log of base. So therefore we have that the relationship between pOH and pH is this. Addition of pH and pOH must always give us 14, right? So whether we are solving for the first one or whether we are solving for the second guy, we must make use of this formula. The nature of the question is what is going to differentiate all of them. Now this H plus is hydrogen ion or a proton, right? It is always found in an acid. Now this is oxonium ion or hydronium ion, so it's equivalent to H plus. So sometimes you can see this expression for pH, and in some other cases you can see this expression for pH, right? We're keeping it simple without stress, straight to the point. You understand it. All right, we have the first case. Remember I gave us 3 cases. The first one I said when the H plus and OH minus concentrations are given to us, and the next one I said when they give us when we are asked to solve for that of an acid. Now the first question says calculate the pH and pOH of the solution with the following concentrations. The first one is 0.001 molar H plus, the next one is 0.025 molar OH minus, and the next one is 0.0. If you noticed in this question, they did not give us an acid, neither did they give us a base. They only gave us the values of H plus. Remember I said H plus stands for hydrogen ion. OH minus stands for hydroxide ions. Now this particularly is found in an acid and this is found in a base. Alright, so they gave it to us directly. All we just have to do is to use these values, insert into the formula for pH, and we get our answer. So I'll start by saying, I'll say solution. Now this, I'll say for the first one, concentration of H plus of the solution is 0.001 molar. Now remember that pH is equal to negative log of H plus. So it simply means that anywhere you see your H plus, you're going to impute this value. So this becomes equal to negative log 0.001. If you press the calculator, your pH is going to give you equals to 3. Alright, if you press the calculator, negative log of 0.001. So that is the answer to that question. Remember, they did not ask us to solve for only pH. They said pH and pOH, right? But since for the first one, they gave me H plus. Class, depending on the values given to me here, that will determine whether I will solve for pH first or pOH first. Now, if you look at the formula for pH is negative log of H plus. And since they gave me H plus first in this first question, that means I need to first of all solve my pH so I can make use of this H plus, right? After which, I will now use a relationship between pH and pOH to get my pOH, right? If I want to solve for the second one, I'll first of all solve for pOH because what they gave me is OH minus, and after which I'll use a relationship to find the pH. So I'll now say, so therefore, the relationship between pH and pOH is equals to 14, which means if I know any one of them, I can solve for the other one. Alright, so this becomes pOH is equals to 14 minus pH, which is 14 minus 3, and our answer is 11. So therefore pOH is 11. So for this first question here, pH is equals to 3, pOH is equals to 11. That is how we got the answer to that question. Now let's look at the next one, B. Now what they gave us here is actually OH minus, not H plus. Alright, so I'll say the concentration of OH minus. Please notice that this square bracket stands for concentration. Alright, so this is going to be equals to 0.025 molar. Now since OH was given to me, what I'm going to solve first is going to be pOH. So I'll say pOH is equals to negative log of OH minus. So that anywhere I see OH minus, I'll put 0.025. Now when I evaluate that with my calculator, I'll say negative log of 0.025. That will give me equals to 1.6. So I have pOH. So that's the value for my pOH. But remember they said pH and pOH. It doesn't matter whichever one that is solved first. At the end of the day, just get your two parameters. Alright, so I've gotten my pOH. So for me to solve for my pH, I'll say pH plus pOH equals to 1.6. But if you noticed, I've already gotten my pOH. So what I need to get this time around is going to be my pH. So I'll say pH equals to, this is equals to 14, not 1.6. Now this is the relationship between pH and pOH. Alright, if you know any one of them, you can get the other one. So if I make this guy subject of the formula, this one crosses over to this side. This becomes 14 minus pOH. So this is equals to 14 minus, our pOH is 1.6. When you press that, this becomes 12.4. So that is the answer for that. So for this second one, our pH is equals to 12.4 and our pOH is equals to 1.6. Okay, now at the end of the day, once I'm done solving, I'll actually put out the scale on the board and explain to us which of the scale, which number is going to be acidic and which of the number is going to be basic. Okay, so let's stick to this video. All right, so let's look at the next one, the C. We have C, H plus is equals to 0.00001 molar. All right, which is equivalent to saying 1.0 times 10 raised to the power of minus 5 molar. All right, so remember I said whichever one you're going to solve first, that is dependent on what is given to you. So since H plus is given to us here, the first thing I'm going to solve will be pH. So I'll say pH is equals to negative logarithm of H plus. Alright, now anywhere I see H plus, I'm going to insert this value. This becomes negative log of 1.0 times 10 raised to the power of minus 5. And the answer to that is going to give me 5. Now let me tell this guy something. Without calculator, I can get the answer for this. Anytime you have value 0.00 ending with 1, right? Now once you take the negative log of that, whatever the exponential is becomes the answer. If you press your calculator, you confirm this. Alright, so we've gotten this to be pH equals to 5. So we'll now say, what is the relationship between pH and pOH? So this becomes pH plus pOH is equals to 14. All right, so we already have pH, so our pOH becomes 14 minus pH. So this is 14 minus 5, and the answer is 9. Okay, so we have pH equals to 5, pOH equals to, okay. Now let's talk about pH scale, alright? So let's say this is 7, this is 0, and this is 14. Now this way is acidic. So if I have pH less than 7, that is acidic. The smaller the value of the pH, the stronger the acid. A pH of 1 is stronger than a pH of 2. That means if a solution has a pH of 1 and another has a pH of 2, it simply means that the one that has a pH of 1 is more acidic than the one that has a pH of 2. Okay? So, if pH equals to 7, the solution is neutral. It's neither acid nor base. Then if pH is greater than this, that is basic. Alright, so with this now, I think with these 3 examples, you should be able to solve any questions under pH that is under direct calculation. Direct calculation, I mean, they gave us the value of H plus and OH minus directly. They didn't give us an acid for us to find the H plus, because in the next case that we're going to be looking at, they give us an acid for us to find the H plus, or they'll give us a base for us to find OH minus. Right, so that depends on whether it is a strong acid or a strong base. If it's a strong acid, it's going to be straightforward calculation. But if it's a weak acid or a weak base, it's not really going to be very straight, but I'll make it to be straight. Okay, so let's look at the next case. Case number 2. Remember, we just completed case 1. Now, case number 2 is a case where you'll be asked to calculate for the pH or the pOH of a strong acid or a strong base. But the issue right there is that a majority of persons don't really know how to differentiate a strong acid and that of a strong base. But ensure you watch this video to the end, so that when we start talking about that of a weak acid, you could actually know how to differentiate a weak acid from a strong acid. Okay, now before we proceed, what are strong acids? No, I'm not here to define an acid. An acid has general definitions, right? A compound that can donate hydrogen ion, right? Under theories of acid and base, I've already discussed extensively what an acid is and the different theories of acid. Now here we only want to specify on the strong acids and the strong base. Now what makes an acid a strong acid? If they say an acid is a strong acid, what makes it a strong acid? Now a strong acid are acid that ionizes or dissociates completely when dissolved in water, right? For example, you have HCl. When you dissolve HCl in water, you have H plus Cl minus. Now, a strong acid is always going to have this arrow, 2-head arrow. Now, whereas a weak acid, anytime a weak acid is written, you always see something like this. This means reversible. Well, we'll get to this shortly. All right, so I said a strong acid are acid that ionizes or dissociates completely when dissolved in water. Now, when we actually start solving this, I will explain the dissociation here. Now, I said example of strong acids, we have the common ones that we know, H2SO4, HCl, H3PO4. Now, this is also known as sulfuric acid, alright? This is also known as sulfuric acid, and this is known as hydrochloric acid, and this is known as phosphoric acid. Take note of that. And I went ahead to say, note, strong acids ionizes completely to give H plus or H3O plus. Take note of that. Now, let's talk about strong base. Now, whether a substance is a strong acid or a strong base, the common thing between both of them is that they must ionize completely. When they come in contact with water, or when they are meant to dissociate, they dissociate completely, not partially like weak acid or base. Now we said strong acids are acids that ionizes completely to produce hydroxide ions. Now let's look at an example that can come under strong acid. If you look at these questions here, they are somehow or somewhat different from the one we did in case 1. This one has acids attached to them, unlike the previous one that they just gave us H plus or OH minus. Right? Now, all of these are strong acids. They are strong acids. How would I differentiate a strong acid from a weak acid? A weak acid will always have Ka value. Anytime you're asked to solve for the pH of a particular substance, right, be it an acid, and then you see Ka. Ka simply means is acid dissociation constant. That means that acid is a weak acid. If it's a weak base, they will give you Kb. Right? In the next section, we're going to talk about this briefly. All right? So let's just come back to this. Now the first one says, calculate the pH and pOH of the following solution. Now these are the solutions. Now the first one is 0.01 molar HCl. So I'll say for the A, HCl, now you dissociate this guy, we have H plus and Cl minus. This is a strong acid, so you can choose to add water, you can choose not to add water, it doesn't really matter. Now based on this, the ratio is 1:1:1. So the concentration of the HCl was 0.01 molar. So since this is 1 and this is 1 as well, this will also be 0.01 molar and this will be 0.01 molar. So having done that, I would say, now listen, an acid will always give rise to H plus. How will I know that this is an acid? It has H plus, H. A base, a strong base will always have OH. Just like I told us previously, a strong base will always have OH. So once you see this, you know it's an acid, and when you dissociate, it will give rise to H plus. Right? Now this gave rise to H plus. That means the concentration of our H plus is equals to 0.01 molar. And once you've gotten the value for your H plus, you can now say pH. Recall that pH is log H plus. Now this is negative log. Anyway you see H plus, you put 0.01 molar. You can remove the molar first. Now this is equals to 2. Our pH equals to 2. But remember, they asked for pH and pOH, not just pH. So this now becomes pH plus pOH is equals to 14. Alright, so our pOH equals to 14 minus pH. So this is 14 minus 2, which is 12. The B part, so the number 2, we have 0.001 molar H2. Now how does H2SO4, sulfuric acid or tetraoxosulfate 6 acid, how do they dissociate? Now H2SO4, when this dissociates, you're going to have 2H plus. Please take note of this dissociation. Anytime H2SO4 dissociates, it's always going to give rise to 2H plus. Because we have 2 hydrogens here, and these 2 hydrogens are acidic hydrogens, right? So they will dissociate as H plus, and then you balance the equation. Here has 2 and here has 1. Okay? Now the ratio here is going to be 1:2:1. Which means if here is 1, here will be 2. So if here is 0.001, here will be 0.002. So we'll say this is 0.001, and this guy will be 2 times 0.001. I am not interested in this because I will not use SO4 2 minus to carry out any calculation. I need H plus because pH, the formula for pH, which is pH equals to negative log. This formula has H plus, so that is why I'm carrying out this dissociation, to be able to know the exact value of H plus so I can substitute into this formula. Alright, so based on this, H plus concentration, remember this square bracket stands for concentration, which is denoted, this M, this molarity, this capital letter M stands for molar, which tells that this is the concentration of this guy. So this becomes 2 times this is 0.002 molar. So insert this into your formula. We have negative log of 0.002, 2.7 approximately. 2.7. All right. So we now have pH plus pOH is equals to 14. Remember, we were asked to solve for pH and pOH. So this now becomes 14 minus 2.7, which is 11.3. We have the third one, 0.025. Now this is a base. So what we are going to be obtaining from here is OH minus, not H plus. So this is the base. So I'll say 0.025 molar. So this becomes calcium. OH minus. But if you look at this, we have 2 of them. That is why we are adding 2 here. And just like in the previous 2 examples, we were interested in the H plus because they were acids. We were not interested in this SO4 minus and Cl minus. In the case of this, we're just interested in the OH because it's a base. So what is the ratio here? 1:1:2. So if the concentration of this guy is 0.025, this will be 2 into 0.025. Alright, so therefore, the concentration of OH minus would be 2 times 0.025. It is 0.05 molar. Now, since we have gotten the concentration of OH minus, right, what exactly are we going to solve for first? Is it the pH or the pOH? Obviously, it's going to be the pOH because the pOH formula has OH is negative log of OH minus. So anywhere you see OH, you put 0.05. Now when you do that, you press your calculator. This becomes negative log of 0.05. So this is 1.3. But remember, you were asked to solve for pH and pOH. Alright? So this now becomes pH plus pOH equals to 14. pH, which is what I'm solving for now, is 14 minus pOH, which is 14 minus 1.3. And the answer is 12.7. Now this is an acid. Alright? That is an acid. 0.001 molar H3PO4. Now this is phosphoric acid or hydrogen phosphate acid. Alright? So let's dissociate this. If you notice, you have 3 hydrogens here. So this will give rise to 3H plus. So we have H3PO4 giving us H plus 3 plus PO4 3 minus. Please take note of that. So we are interested in H plus. We are not interested in this because this is an acid. An acid will always give rise to H plus when ionized or dissociated. So this is 1:3:1. So if here is 0.001, here is going to be 0.001. 3 times this right? 3 times this because the ratio is 1:3. So therefore our H plus is 0.003 molar. Alright, so when you now come here, you say since I am asked to solve for an acid, for the pH of an acid, they gave me an acid. From this acid I've gotten the H plus because the formula of pH needs H plus. So I've gotten the value of H plus, so all I just have to do is to replace this value into this formula of pH. So this is negative H plus, which is negative log of 0.003. So if you press your calculator, we have negative log of 0.003. This equals to 2.5. So pH of this is equal to 2.5. But once again, remember, we were asked for pH and pOH, not just pH alone. So we'll say pH plus this is equals to 14, which is 14 minus 2.5. This will give us 11.5. Alright, so pH is 2.5 and pOH is 11.5. Now the last but not the least, so let me just solve this. Now for the number 5, they gave us 0.1 molar NaOH. Now this is a base by virtue of having OH. It's a base. So when this dissociates, it will give rise to OH minus and Na plus. So this is we have Na plus OH minus. The ratio is 1:1:1. So this is 0.1. The value of this is 0.1, so the rest is going to be 0.1, but I am not interested in Na plus. This is what I'm interested in. I'll just put it for formality's sake. So therefore, concentration of OH is 0.1 molar. So since I have OH, what I am going to solve for first is not going to be pH, it's going to be pOH, because pH has H plus in its formula, whereas pOH has OH minus in its formula. So the one I'm going to use is the one that has what I have here. So I will say pOH is equals to negative log of OH minus. So this becomes negative log of 0.1, which is 1. Alright, so you now say pH plus pOH is equals to 14. pH equals to 14 minus pOH. So this is 14 minus 1. And the value for your pH is 13. So having done this, we've actually completed the first two cases of calculations under pH. The last case is actually that of a weak acid and a weak base, and of course that is more little complex than the first two. But if you actually understand the concept behind the first and the second, the third one, I'll give us a shortcut. You don't really need the necessary stress, but I will explain and tell us how you can go about it, and then follow it up with the short method to solve it. All right, please, if you're new to this channel, please do also hit the subscribe button, right, and share the video. Thank you. This is case 3. Now in the previous two cases, we've solved for pH when H plus concentration and OH concentration was given. We also solved that when that of a strong acid is given. Now this particular section, we want to talk about pH, how to calculate pH and pOH of a weak acid or a weak base. First and foremost, what is a weak acid? Weak acids are acids that dissociate partially or ionizes partially when dissolved in water or aqueous solution. And what are weak bases? They dissociate partially. Now, One major deciding factor, or what differentiates a strong acid and a weak acid, is their ionization strength. Strong acid dissociates or ionizes completely, whereas weak acid ionizes or dissociates partially. Okay, example of weak acid: all organic acids are weak acids. Example, we have the carboxylic acid, which is ethanoic acid. We have the benzoic acid. We have phenol. Phenol is not an acid per se, but they can act as an acid. We also have HF. Hydrofluoric acid is a weak acid. Okay, now in this particular section, or in this particular video, we want to talk about how to carry out pH calculations of a weak acid. But there's one thing you need to understand, that since a weak acid dissociates partially, there's bound to be an equilibrium constant. Okay, so if you're asked to solve for the pH or pOH of a weak acid, class, they must give you acid dissociation constant, that is Ka. If you're asked to solve for pH of a weak base, they'll give you Kb. All right, so let's look at some few examples and then explain how we can solve that. All right, okay, so we have some few questions here on the weak acid. If you could recall what I told us earlier in the video, if you're asked to solve for pH of an acid, and of course you see this Ka stands for acid dissociation constant. Ka is acid Now, it is acid dissociation constant. Once you see Ka, just know that that is a weak acid. So there is Ka. As far as this particular topic is concerned, you can be asked to solve for the pH of a weak acid, and then they'll give you your Ka, right? And the concentration. Or you can be asked to find the Ka. pH this time around will be given, and the concentration will be given. So let's start with this. So I'll say for the first one, so we have concentration of the acid here is COOH equals to, the concentration is 0.3 molar. Class, do not forget that this square bracket stands for concentration, okay? And then Ka equals to 1.8 times 10 raised to the power of minus 5. Now, every weak acid, when dissociates, does that partially. So let me just give us a preamble so that we understand what a weak acid, how it dissociates. I'm going to give us the general formula for weak acid dissociation, okay? Now, let's say a weak acid is Ha. Now, when this dissociates, remember, for weak acid, you can choose to add water, or you can choose not to add the water. But when we're talking about, when we finally get to weak base, you must add the water. So when this dissociates, we have H plus this. Now the Ka, this is aqueous. Now the Ka for this, now the Ka for this will now be, now acid dissociation constant is written the concentration of the product to that of the reactant, all right, ratio of the concentration. So we have H plus A minus. Now this is Ka for every, this is the same way, this is how we write Ka expression for all weak acids, whether it is carboxylic, whether it is ethanoic acid, or it is HCN. All weak acid takes this general form Ha. All right, so you don't really have to start doing that for CH specifically. This particular guy has covered the general formula for an acid. Okay, now this is what we have here. So I haven't done that. I'm going to clean up the board and restart solving this. Now, if you're asked to solve for the pH of a weak acid, now follow me. I want to show you guys how to do it. So let's say, I'll say let concentration of the acid equals to C dot A. Remember, the formula for pH is pH equals to negative log of H plus. So this is what we want to find from this acid. Once we're able to get this from this acid, automatically we insert it here and we get our answer. Okay, now do not forget that every acid is going to give rise to, now every weak acid, this is the dissociation equation, here is reversible arrow. Now class, when an acid dissociates partially, it simply means that this hydrogen is just a little amount that came out from this main acid. This is what we need so that we can put it into this formula to solve. In the case of a strong acid, we said 1:1:1. But since this is a weak acid, not everything here came out from this. So it's just a little amount. We do not know that little amount, okay? So the concentration of this is 0.3. We cannot say here to be 0.3 because it did not dissociate completely. It was partially. So it's just a little amount that came out from this 0.3. We do not know the amount. So we call here to be X. If here is X, here will also be X because here is 1 and here is 1. So their ratio is the same. Okay? Now, we now say Ka, concentration of H plus, concentration of A minus, all over concentration of HA. They give us this to be 1.8 times 10 raised to the power of -5. But remember, this is what we are looking for. We do not know it, so we had earlier said let it be X. Okay, so I'll come here and say anywhere I see this, I'll put X. Anywhere I see this, I'll put X. The concentration of this is 0.3. This is equal to 1.8 times 10 raised to the power of -5. Okay, now X times X is X squared. If you cross multiply, this comes over to this side, so this becomes 0.3. So when you press your calculator, you have square root of, you now say X is now square root of 0.3 . So the value for X is 2.32 times 10 raised to the power of -3. All right, remember we had earlier said let X be the concentration of H plus. So now we have gotten the value of X. So we just come back here and say X is equals to concentration of H plus, which we got here to be 2.32 times 10 raised to the power of -5. Now pH equals to negative log of H plus. This is negative log. Anyway you see H, this H plus, you put 2.3 times 10 raised to the power of -5. So we have -3. This is -3. So this becomes negative log. So we have our pH equals to 2.63. Now this is a bit lengthy, all right? I'm going to just bring this in just some few lines, just in case of exams, because most of the times exams is always asked and then the number of lines given to us to insert our answers is always very small. So let's solve it in a shorter way, shorter than this. Okay, so like I said, let's reduce the solving. Let's assume in exams they gave you a subjective question or objective and you're just asked to solve this. Now first thing first, for you to solve for pH, you need to know H plus, right? And in the case of H plus for a weak acid, you have to write the expression, which is not necessary. So what we need to find is H plus. From what I did previously, we had said that H plus, let it be equals to X. So once you've gotten the value of X, which is your H plus, we can solve. So this becomes the concentration of H plus. You can just simply do this in exams. Concentration of H plus is always square root of concentration of the acid times acid dissociation constant. All right. So this becomes our H plus. So therefore, H plus equals to, now what is the concentration of the acid? 0.3. 0.3. What is Ka of this acid? 1.8 times 10 raised to the power of minus 5. And from our calculation, we got 2.32 times 10 raised to the power of minus 3. So pH will now be negative log of this, which is negative log of 2.63 approximately. So this is the short method. So we're going to use that to solve the second guy. Okay. So we're going to just use that short method to solve for this. You're asked to solve for the pH of a 0.29 molar solution of HCl. I am not interested the type of weak acid that is. As long as I've gotten my Ka, the formula for the weak acid is irrelevant. So I'll say, how do I get my H plus? Because for me to solve for pH, I need my H plus. So H plus is equals to square root of concentration of acid times Ka. And this is equals to, what is the concentration of the acid in this case? 0.29. So we'll have square root of 0.29 times, what is the value of Ka here? We have 4.9 times 10 raised to the power of minus 16. So this is equals to 1.19 times 10 okay. So this is what we have. So we now say that's answer for that. So the pH for this is this, as simple as ABC. So this short method, you can use it in exams. Okay. Now let's look at number 3. All right. So I've written out the parameters for this. They say lactic acid has one acidic hydrogen. Right? Acidic hydrogen simply means if this guy dissociates, right, it can only give rise to one hydrogen. Now, a 0.1 molar solution of lactic acid has a pH of this. Calculate the Ka. Now look up. This is basically the opposite of what I taught us previously. Now, remember, for a weak acid, we have Ha equals to H plus A minus. Now, Ka, now do not forget that the ratio of this, both of them are having 1:1. So here is going to be X and here is going to be X. Now, the reason why we are putting X is because this acid is dissociating partially. So this H cannot have the same value of the acid because it's just small amount of this guy came out from this. So the concentration of this guy remains 0.10. So if I should write Ka will now be this. We do not know the value. So anywhere I see this guy, I'll put X. Anywhere I see this guy, I'll put X because both of them are in the same value. And this is all over 0.1. Now, they are asking me to find the Ka. And what is missing out here is the X. But remember that this X is the concentration of H plus based on this. Whatever the value of this X is, that will become the concentration of H plus, and that will also become the concentration of A minus. All right. And recall that if you know the value of pH, you can actually get the value of H plus. Now, from pH equals to negative log of H plus, right? I can say H plus will be anti-log of minus pH. Please take note of this formula. If you know H plus, you can solve for pH by simply using negative log of H plus. However, if you know pH, you can actually solve for the H plus, so it's more like a vice versa. Okay, so this becomes equals to anti-log of minus, what is the pH in this question? 2.44. So when you solve for that, anti-log of that, we have shift log minus 0.63 times 10. Now this is the value of H plus, right? This is the value of H plus. So remember, whatever the value of H plus is, that will be the same value of A minus. So this is X equals to this. So I can now come here and say, so therefore, my Ka equals to X times X all over 0.3 or 0.1. So this is equals to, anywhere I see X, I'll put 3.63 times 10 to the power minus 3 times, because it's X times X, which is same thing as X squared. So I can simply say just square this guy. Remember, X times X is X squared, all right? Now this is all over 0.1. Okay. Now that is the answer for that Ka. So we have a few examples under weak base. Now weak base and weak acid, their calculations are almost very similar. The only difference is that for weak base, you need Kb, that is base dissociation constant. In the case of acid, it was Ka, acid dissociation constant. Okay. Now they said calculate the pH of 0.01 molar ammonia solution. Now what you simply need to know if the solution is an acid or a base is the base dissociation constant. But once you see Kb, whether there is OH or not, just know it's a weak base. If it's in the case of an acid, once you see Ka, just know it's a weak acid. Now let me guide us on how weak base dissociates. Now let's say, for example, ammonia. Base, you must add water. For base dissociation, you must add water. In the case of acid, remember I said water is optional for an acid, right? That of acid, I gave us Ha, H plus. Now this is without water. Now if I add water, it will be this. In the place of H plus, it will now be H3O plus. Now this will lose the hydrogen and this will accept it to have this. Now this is in the case of a weak acid. You can choose to add the water or you can choose not to add the water. You're correct. But in the case of a base, it's a must. You must add water. You must add water. Take note of that. So for base, this will donate hydrogen. So have B. How did we arrive at this? This water this is a base and this is acting as an acid. So this water, acid will donate hydrogen plus and this will accept it. So from this, once this water have lost hydrogen, it becomes this. So my Kb, this is aqueous, this is liquid. Please take note, water being in a liquid form does not take part in the equilibrium constant expression. So the Kb for this will now be now this is a Kb for that. Water is not included, right? Okay. Now remember what I told us previously, okay, when we did acid. So we're going to follow that same pattern, the shorter method. So here, sorry, I want to rewrite this. So this is B plus water I want you to observe something. In the case of a weak acid, what the product contains H plus or H3O plus. Whereas in the case of a weak base, the product contains OH minus, right? Now, if you're asked to solve for pH for a weak base, you have to first of all solve for pOH because a base will always give rise to OH, like in this case now. So if you get the value of the OH, you solve for pOH. Once you've gotten the answer for pOH, you now use the relationship between pH and pOH to get your pH. Okay, so remember I said the ratio of this is 1:1. So if here is X, here will also be X. Pay attention, class. Now the concentration of this, in that question they gave us to be 0.01. Now this formula is used for all type of weak bases. In this question, ammonia is a weak base, right? But I did not bother writing ammonia. I simply used a general representation for base, which is this capital letter B. So whether it is ammonia that is there or anything else, it doesn't matter. So the concentration of the base is 0.01. Now, but this is not going to ionize completely, which means the value of OH is not going to be the same thing as this, irrespective of the fact that here is 1 and here is 1. There was no complete dissociation. Okay, so whatever this guy is, we do not know, so we call it X. So since this and this are in the same ratio, 1:1, here will also be X. All right, so I'll simply say my KB will now be, how do we write the expression for KB? This is it. The concentration of this BH plus, we do not know it, so we put X. That of this guy, we put X. And this is 0.01 equals to, this is 1.8 times 10 raised to the power minus 5. Now this is X squared equals to 0.01 times 1.8 times 10 raised to the power minus 5. If you make X subject of the formula, this becomes 0.01. So our X now remember, since this is a weak base, this X stands for OH minus. So I can simply say, so therefore, concentration of OH minus is 4.24 times 10 raised to the power minus 4. Now, since we have gotten the value of OH minus, we can now proceed to solve for pOH. And after which, we'll solve for pH. So I'll be cleaning this to solve for the pOH. So now say pOH is equal to negative log of OH minus. So this is equal to negative log of, what is the value of OH minus? Now this is the value of pOH, but remember, we were not asked for pOH, we were asked for pH. So we now say pH plus pOH equals to 14. Alright, so pH equals to 14 minus pOH, which is 14 minus it is 10.7. So that is the answer for that pH. Remember, I showed us shortcuts when we did weak acid. Alright, so I'm also going to show that shortcut for this weak base just in case of exams. Now for solving pH of a weak base, first thing first, you have to solve for your OH minus. And how do you solve for your OH minus? Same thing like what I showed us earlier. Square root of concentration of the base times Kb. Alright, now pOH will now be equal to negative log of OH minus. My pH will now be 14 minus pOH. Now, let's solve for this using this question. Now, the concentration of OH minus would be equals to concentration of the base, which is ammonia, is 0.01 times our Kb is 1.8 times 10 raised to the power minus 5. Now this is the concentration of OH minus. Now we now proceed to say .37. Now our pH is now 14 minus 3.37, which is 10 points to what we got earlier. So this is a short method. So you choose between this method and the previous one. Okay, whichever of them is actually suitable for you. For me, I'll go with this because nobody loves stress. They will not give me extra mark for stressing myself. So why would I want to stress myself? Okay, so let's solve another question here. Now this is very similar to question number 3 when we solved for that of acid. Now they said we should solve for, they gave us the pH of this solution, and then the pH of this solution, this is the concentration of the solution, and this is the pH. And we are asked to solve for base dissociation constant, which is Kb. So first thing first, this is what I'm going to do. I'll say pH of this guy is 0.0. pH of this guy is 9.35. Concentration of the solution equals to 0.056 molar. Now, Kb is what we are asked to find. How do we go about it? Remember, this is a base, right? Base will always give rise to OH minus, right? Base will always give rise to OH minus. But before we proceed, let's do this. Remember, this is expression for base. This is a liquid. So we're going to have B, H plus, and OH minus. So our Kb is equal to concentration of BH plus now we know the concentration of the base, which is 0.056. So what we just need is to get the value of this and this, insert it and solve for our Kb. But we do not know the value of OH. Okay, now if we do know the value of OH, we call here to be X. And since OH is having the same mole as that of this, it will also be X. So this expression will now reduce to X times X all over, which is X squared. So we need to find the value of OH. Once you've gotten the value of OH, that becomes your X. And once that becomes your X, this also is your X. Now this is what we're going to do. They gave us pH. Remember, if pH is known, you can get the value of H plus. From what I told us, from pH equals to negative log of H plus, you can actually get your H plus from here. Anti-log of minus pH. Remember, I told us this. So them giving us pH, right? We can solve for H plus directly, but we do not need H plus. So how do we get our OH minus? So for me to get my OH minus, I will say pH plus pOH is equals to 14. All right. So this becomes pOH is 14 minus pH, which is 14 minus, my pH is 9.35. This is our pOH. So remember, pOH is equals to negative log of OH minus. So I can equally say OH minus equals to anti-log of pOH. Okay, so this is anti-log of minus 4.65. Now that is the concentration of OH minus. Now since we have gotten the concentration of OH minus, all we just have to do is to come here. Now don't forget that this OH minus is sent as X here. And X, whatever the value of OH minus is, would be the same value of this because their ratio is in 1:1, right? Take note of that. So I'll come here. Now this is concentration of the base now. That is our value for KB. Okay, so if you have any question under this calculation, please drop a comment and I will be there to answer you. Now let's look at the relationship between KA and KB. What is the relationship? Because in the case of the exam, they can ask you, what is the relationship between KA and KB? Now the relationship between KA and KB as follows. Now KA times KB is always equals to KW, and KW is ion constant of water. KW will always have a value of 1.0 times 10 raised to the power of minus 14 at 25 degrees Celsius. So therefore, Ka times Kb equals 1.0 times 10. So in case you're asked to give the relationship between Ka and Kb, so in case you're asked to give the relationship between Ka and Kb, this is the relationship. Now Ka is acid dissociation constant and Kb is base dissociation constant. Now this formula can be reduced to pKa plus pKb equals to 14. Just in case you're asked, relationship between pKa and pKb, it is equals to 14. Relationship between Ka and Kb is this. Now look at this. Between Ka and Kb, we have a multiplication sign. Between pKa and pKb, we have addition sign. Okay? Take note of that. And another formula I need us to take note of is relationship between pH and pOH. All right, so if you have any question, please do not hesitate to drop it on the comments. All right.